What if I told you that spending 14 times more on a premium AI model might actually make your autonomous agent perform significantly worse?
Yeah, which sounds completely counterintuitive, right?
Right.
But it's actually happening.
Exactly. Welcome to the deep dive.
Yeah.
Look, if you are building, managing, or you're just using AI agents right now, you definitely know the reality here.
Oh, absolutely. The demo phase.
Right. It takes like an hour to build this flashy demo that looks like absolute magic.
Yeah.
But the second you try to actually deploy that agent to real users,
You hit a massive wall of
a
uncertainty.
huge wall. Because how do you actually know if that agent is reliable or safe or even cost-effective once it's out in the wild?
Well, most teams, frankly, don't know. And that uncertainty creates what the sources where I'm packing today call the WebMD panic spiral.
The WebMD panic spiral. I love that term.
Right, because AI models are probabilistic.
Mhm.
They don't produce the exact same output every single time. So engineering teams start to lose trust in their own software.
Yeah, they see the agent behave erratically once, and suddenly they're questioning everything.
Exactly. And a lot of teams just revert to manually typing these weird edge case prompts into a chat window, just hoping to see where the system breaks.
Which is, I mean, let's be honest, that is entirely unscalable. If you're building traditional software, having your QA team manually click around a website to find bugs is embarrassing enough.
Yeah, no pitch.
Doing that for a multi-layered AI agent, you're practically flying blind.
It's an absolute engineering nightmare. So our mission for this deep dive is to map the way out of that spiral.
Let's do it.
We are looking at a stack of sources that cover over 30 LLM evaluation of benchmarks, the whole landscape of testing frameworks, and specifically, we're exploring a new open source framework called Litmus AI.
Right, Litmus AI.
Yeah, they're basically replacing all that manual guesswork with hardcore engineering rigor, economic forensics, and this really fascinating concept called deterministic geometry.
Okay, definitely want to get into the deterministic geometry stuff, but let's start with how we got here. Because, you know, the way we grade AI has evolved incredibly fast.
It really has.
In the beginning, we basically just used standardized tests. The sources highlight these static benchmarks that kind of became the industry standard.
Right, the early days of evaluation.
Yeah. So you have like MMLU, which tests general knowledge across 57 different academic and professional subjects.
Mm-hmm.
And then there's HelloSwag, which it tests common sense reasoning. It gives the model a scenario and forces it to pick the most logical ending.
Right.
And, you know, human evil for coding tasks.
Right, and those static benchmarks, they were crucial when models were smaller. I mean, they gave us a fixed set of text inputs with known, verifiable ground truth answers.
A level playing field, basically.
Exactly. Researchers could mathematically compare a model's accuracy, but there's a huge catch now.
Right, because, wait, if these models are training on petabytes of data scraped from the entire internet, haven't they already, you know, processed these exact test questions during their training runs?
Yes. Yes, they have.
So it seems less like a test of reasoning and more like an open book test where the student already has the answer key in their pocket.
You hit the nail on the head. That is a massive structural flaw, and the industry calls it data contamination.
Data contamination.
Oh, yeah. If a model has already seen the HelloSwag benchmark during its pre-training phase, scoring highly on it doesn't prove it actually understands common sense reasoning at all.
It just proves it has a really good memory.
Exactly. So we realized pretty quickly we can't trust static text files anymore, which explains the shift to dynamic evaluation.
Okay, so looking at the landscape, the next evolution was this LLM-as-a-Judge model.
Right, fighting fire with fire.
Yeah. Instead of relying on a fixed answer key, developers were like, let's just use a secondary AI to read the primary AI's output and score it based on a custom rubric.
Which is a huge step up, but it required immense specialization to actually work well.
How so?
Well, for example, Patronus AI developed this model called Glider, and it's built on a much smaller, cheaper architecture, specifically the Phi 3.5 mini-instruct model.
Okay.
But it is completely fine-tuned just for high-volume screening, so it doesn't just say pass or fail. It actually highlights the exact spans of text it used to make its judgment.
Oh, that's clever.
Yeah.
And Google took a really similar route, right, with their LLM comparator tool.
Yes, exactly.
The sources mentioned they introduced a visual dashboard called a rationale summary.
Which is huge for developers.
Right, because if you're an engineer comparing two different models, you don't just see like, oh, model A1.
Yeah.
You actually get a visual breakdown of exactly why the judge model preferred it.
Yeah, the focus really shifted from simply getting the right answer to demanding that the evaluating model explain its reasoning.
And this is a but even with rationale summaries, having an AI grade another AI hits a pretty severe bottleneck once we stop talking about simple chatbots.
Oh, absolutely. The second you move to autonomous agents, the whole game
The
changes.
mechanics are just fundamentally different, right? I mean, a
Yeah,
chatbot takes a prompt, generates some text, and stops.
exactly. It's a single turn.
But an agent executes a multi-step workflow. It might receive a prompt, decide it needs to query a SQL database, extract a specific row of data, write a Python script based on that data, and then send the result in an email,
Right, and every single one of those steps multiplies the chance of a catastrophic failure.
which creates a massive production gap.
It does. Evaluating that kind of multi-turn logic requires specialized benchmarks. The sources mention Agent Bench and GAIA, which specifically test tool use and, environmental interaction.
Okay.
But more importantly than just benchmarks, it requires entirely new testing pipelines.
And the tooling landscape for those pipelines is incredibly fractured right now.
Right.
I mean, looking at the sources, for solo developers, prompt foo is immensely popular.
Oh yeah, prompt foo is everywhere.
It's great because it lets you run prompt tests locally on your command line using like simple YAML config files.
Very fast, very lightweight.
Right. But the sources note a really severe friction point. When that solo developers company starts to scale, prompt foo's local terminal-based nature becomes a huge liability.
Oh, for sure. Product managers and QA teams do not live in the terminal,
Exactly. They get completely locked out of the evaluation process.
which is terrible for cross-functional teams. That friction forces organizations to adopt heavier enterprise-scale platforms.
Like what?
So you see tools like Braintrust, which uses a really high-speed query engine to connect live production data, like the actual requests your users are making directly back to your evaluation data sets.
Oh, so you're testing on real user behavior, not just hypotheticals.
Exactly. Or there's ZenML, which treats evaluation not as this separate isolated test, but as a continuous pipeline workflow.
Right. Pipeline first tracking.
And we also have to mention RBERIS. That one is specifically designed for retrieval augmented generation, or RAG pipelines.
RGRAG is huge right now.
Right. And RAGS is unique because it can score how relevant a retrieved document is without actually needing a human-provided ground truth answer to compare it against.
Okay, let's unpack this for a second, because if I'm a traditional software engineer coming into this space, this all sounds, well, unnecessarily complex.
I hear that a lot, yeah.
Right. Like in standard software development, if I write a function that adds two numbers, I just write a unit test, checking if the output matches my expected string. Why can't we just use standard string matching tests for AI outputs?
Well, because of the entropy of language models, as we touched on earlier, LLM outputs are inherently non-deterministic.
Right.
So if you prompt a model to explain why the sky is blue, it might say the sky appears blue due to Rayleigh scattering one time. But the next time, it might say Rayleigh scattering makes the sky look blue.
The semantic meaning is totally identical, but the actual characters in the text are completely different.
Exactly. And standard software testing is highly, highly literal. If your unit test demands the exact substring, the sky appears blue, that second answer will trigger a test failure.
Even though the model is completely correct.
Right. Standard unit tests will just generate constant false negatives. And furthermore, running a test once tells you almost nothing in AI.
Because of that variance.
Exactly. If an agent succeeds on the first try, you have absolutely zero statistical confidence that it will succeed on the 10th try.
And that structural engineering dilemma is exactly where Litmus AI enters the picture. They are completely changing the paradigm of how we evaluate agents.
They really are.
Yeah.
They're moving teams away from vibe-based testing.
Vibe-based testing, where a developer just like eyeballs the output and goes, yeah, looks good to me.
Right, exactly. And they're moving away from those fragile exact match strings we just talked about. Litmus AI essentially treats prompts as code, but it introduces the nuance you actually need to evaluate probabilistic systems.
And the way they handle this is through 15 specific assertion types, right?
Yes, 15 assertions.
So instead of just looking for text, Litmus AI parses the intent. Like one assertion the sources mentioned is numeric extraction.
That's a great example.
Right. It understands that the written word 26, the Roman numeral XX6, and the integer 36 are mathematically identical.
Exactly. Another critical assertion type they use is JSON schema validation.
Okay, we need to unpack that because JSON is basically the lifeblood of agent tools right now.
It absolutely is. Think about it. If your AI agent needs to book a flight, it can't just output English text to the airline's API.
Right. The API would have no idea what to do with, hey, book me a flight to New York.
Exactly. It has to output a perfectly structured JSON data object. It needs specific keys like destination and departure date. If it misses a single comma or formats the date wrong, the tool call fails and the agent crashes.
Just completely breaks.
Yes. So Litmus AI doesn't just check if the text looks generally right. It structurally validates that the agent's output perfectly matches the strict schema required by that external tool.
They also use semantic similarity checks, which is cool, and these composable logic wrappers like all, any of, and at least.
The composability is where it gets really
Yeah.
powerful.
So an engineer can build a testing tree that says, like, pass this test as the output contains the correct JSON schema, and it extracts the right numeric value. And it is semantically similar to this core concept.
Right.
It's the difference between asking, does this paragraph look okay, and putting the output under an incredibly precise microscope.
It allows teams to build highly complex pass and fail conditions. But, while that accuracy is paramount, Litmus AI introduces another feature that solves a massive, massive business problem.
Oh, the economic forensics.
Economic forensics, yes.
Yeah.
The actual cost of running these models.
Because when you build an agent, every token of text it reads and generates costs, a fraction of a cent.
And those fractions add up fast.
Yes.
Most evaluation platforms out there try to estimate these costs using local token counting libraries like OpenAI's tick token.
Right.
But those estimates are notoriously inaccurate. Tokenizers are essentially dictionaries, and different model providers use entirely different dictionaries.
That makes sense.
Plus, when an agent calls a tool, there's all this hidden metadata passed back and forth that local libraries completely miss. The sources show these estimates can actually be off by 10 to 20%.
Wait, 10 to 20%. If you have an agent processing like 100,000 customer service tickets a day, a 20% margin of error on your computing bill is catastrophic.
It's a CFO's worst nightmare. So Litmus AI bypasses the estimation entirely. It calculates a metric called cost per correct answer.
Cost per correct answer.
Yeah, and it uses the real verified API billing data returned directly by the model provider.
And the benchmark data they gathered using this forensic approach is wild. Let me share this because the sources are super clear here. They ran a complex agent task suite across several frontier models. GPT 4.1 passed 100% of the assertion tests, and its real cost was 0.00034 cent per correct answer.
Very efficient.
Right. Then they ran Anthropic's Claude Opus 4. It only passed 83% of the tests, but it cost 0.0085 sides per correct answer.
Which is just a staggering difference when you look at the business implication of that math.
Yeah, here's where it gets really interesting. Are you telling me the significantly more expensive model was actually worse at the task?
That is exactly what the data shows. Claude Opus 4 cost 14 times more per verified correct answer than GPT 4.1, while delivering a noticeably lower overall success rate.
If I'm a CTO approving a massive budget for a premium model like Opus, I'm expecting it to be virtually flawless. How is it performing worse while costing 14 times as much?
Well, it highlights a really critical blind spot in the industry. People assume more expensive or larger parameter count automatically equals more capable at your specific task.
Right, bigger is better.
But that's a myth. An agent relying on heavy tool use might actually get confused by a larger model's tendency to over-explain things, whereas a smaller, cheaper model might just output the clean JSON schema perfectly about the fluff.
Oh, that's fascinating.
Yeah. Without a tool like Litmus AI, tying verified passing assertions directly to real API receipts, engineering teams are just flying blind. They're buying perceived prestige rather than actual utility.
They're just throwing money at the problem. So, okay, you track the economics, you lock down the formatting, and you optimize for the highest pass rate at the lowest cost.
Right.
But none of that matters if your autonomous agent does something malicious. Because agents take real actions, right? They read databases, they send emails, they alter files.
Their attack surface is exponentially larger than a standard chatbot.
Exactly. So we have to pivot to security. The vulnerabilities are terrifying.
They really are. And Litmus AI's architecture treats safety as a foundational layer, not just an afterthought. They integrate automated red teaming directly into the CI/CD pipeline.
And for anyone newer to the dev side, CI/CD is continuous integration and continuous deployment. Meaning, every time a developer updates the agent's code or tweaks its system prompt, a gauntlet of tests runs automatically before that update is allowed to go live.
Right. Litmus AI tests the agent against 46 distinct attack types spanning 7 categories.
46 types. Wow.
Yeah, we are talking about prompt injection, where a user tries to hijack the agent's instructions, jailbreaking, data exfiltration attempts,
Right.
PII leakage, where the agent is tricked into revealing sensitive, personal user data.
And the sources share this really specific, frankly alarming reality check from one of these scans. They ran a GPT 4.1 agent through this 46 attack pipeline. The agent scored a failing 78 out of 100.
Yeah, it failed hard.
In one instance, when subjected to an injection test, the agent literally replied with the word hack.
Which is terrifying.
And in another test, it just echoed back a malicious French injection prompt verbatim.
And that right there demonstrates exactly why manual testing is a complete fantasy.
Oh, yeah.
I mean, a developer trying to break their own agent is never, ever going to think to manually type a zero-day injection attack in French.
Never.
You need a system that dynamically generates adversarial prompts at scale. And this requirement for scale ties directly into Litmus AI's multi-run execution feature. They call it the pipeline object.
Ah, the pipeline object. Because, again, we're dealing with non-deterministic models, so running an attack once isn't enough, right?
Exactly. The pipeline object might take that single French injection attack and throw it at the agent 5 separate times in a row.
So if the model deflects the attack 3 times, but leaks data the other 2 times.
You have a highly unstable system.
Wow.
If you only ran the test once and it happened to be one of the 3 successes, your pipeline would show a green check mark. You would deploy that agent thinking it's totally secure.
That's a scary thought.
Multi-run statistics expose that underlying variance. A 60% pass rate is a catastrophic failure when we are talking about database access.
If you connect an AI to your company's database,
Okay.
a 60% success rate isn't a passing grade. It's basically playing Russian roulette with your user data.
You absolutely need statistical certainty to ship to production. But that brings us to the ultimate friction point in all of this.
Okay, what's that?
Even with 46 automated safety checks, and even when running them 5 times over to find variance, if you are using an LLM as a judge to evaluate the results, you are still relying on a probabilistic model to evaluate another probabilistic model.
Right. It's like having a high school student grade another student's calculus exam when neither of them actually has the teacher's rubric. They're just kind of guessing based on what looks right.
It creates a circular failure loop. Using an LLM as a judge introduces positional bias, where the model arbitrarily prefers the first answer it reads.
Yeah.
It introduces circular logic, where the model justifies a wrong answer just because it sounds eloquent. It is entirely subjective. As the source material bluntly summarizes, a system that hallucinates cannot reliably detect hallucinations.
Which leads perfectly to Litmus AI's ultimate evolutionary edge, the absolute climax of their approach. They're building a way to bypass probabilistic judges entirely.
Yes, this is the breakthrough.
They are replacing the subjective LLM judge with deterministic geometry.
It is a profound shift in how we process language. Litmus AI is utilizing geometric algebra to detect hallucinations without needing a secondary AI at all.
Okay, stop right there. Let's ground this. For those of us listening who aren't mathematical physicists, what does deterministic geometry actually mean in practice? Like, how do you apply math to a hallucination?
It's actually really elegant. Think about how a model understands language. It breaks concepts down into data points. Litmus AI takes the semantic meaning of the agent's output, the factual claims it's making, and the original context it was provided.
Okay,
It then represents all of those dimensions as high-dimensional vectors.
let's use an analogy here. Imagine a 3D map. If you map the word apple and the word orange, they're going to be placed very close together as coordinates because they're both fruit.
Right.
But the word car is going to be mapped miles away on a completely different axis.
Exactly. Now take that 3D map and scale it up to thousands of dimensions, capturing incredibly subtle nuances of meaning, logic, and fact. Litmus AI maps the ground truth context you provided, and it maps the actual output the agent generated.
Okay.
It then calculates the mathematical distance, the geometric alignment between those 2 vectors.
So it takes the subjectivity completely out of the evaluation.
Completely.
We aren't asking an AI, hey, does this look generally right to you? We are measuring the literal mathematical distance between what it said and what is actually true.
Yes. And Litmus AI allows you to set a strict deterministic threshold for that distance, say 0.60. If the mathematical alignment score falls below 0.60, the system instantly flags the output as a hallucination.
Instantly. No secondary LLM call required.
None. It relies on hard math. This saves massive amounts of processing time, it drastically reduces evaluation costs, and it completely eliminates the risk of your judge model hallucinating.
And because it's just math, it's incredibly fast. Which is why the sources show that Litmus AI isn't just for testing before launch in your sandboxed environment. It actually acts as a runtime reliability layer.
Yes, exactly. A proxy service.
Right, a proxy service that sits between your agent and the real world.
This is the bridge from testing to active protection. When your live agent is interacting with a customer and attempts a tool call, that action is intercepted by the Litmus AI proxy. The geometry vectors are calculated and validated against your strict policies in real time within milliseconds.
So if a deployed agent hallucinates and tries to execute a command to, say, delete a user's record without verifying their confirmation token, the proxy catches the misalignment immediately.
It blocks the malicious call instantly, logs the vector divergence, and forces the agent to safely reroute its logic without ever exposing the database to the error.
That is incredible. So synthesizing all of this, the journey of evaluating AI has undergone a complete metamorphosis.
Total paradigm shift.
We started with static, easily memorized benchmarks, like MMLU. Then we moved to LLM-as-a-Judge, which gave us dynamic grading but introduced subjective hallucinations and bias.
Right.
And now we were arriving at the robust, engineering-first reality of tools like Litmus AI. We've learned that vibe-based testing is dead.
Oh, completely dead.
More expensive absolutely does not mean better. And relying on real API costs, multi-run stats, and deterministic geometry is pretty much the only way to ship AI agents with actual confidence.
We're finally building the high-resolution diagnostic tools that this industry has been missing. We're replacing the blurry guesswork with mathematical certainty.
And as we look forward, the source material leaves us with one final, truly provocative thought. As these autonomous agents become ubiquitous, handling our company finances, managing medical data, executing contracts, evaluating them, won't just be an internal engineering task.
It will be a prerequisite for public trust.
Exactly. Imagine a near future where platforms like Litmus AI issue verifiable AI literacy certificates.
You love that concept.
Using adaptive GPT-powered testing to mathematically certify that an agent meets strict safety and factual benchmarks in under 5 minutes before it is ever allowed to interact with a human being.
An actual mathematically verified driver's license for autonomous software.
It really makes you wonder, as this mathematical validation becomes the standard, how will verifiable AI certification change the software you trust tomorrow?
It is the ultimate question for anyone building in this space.
Well, that's it for today's deep dive. Thanks for listening, and we'll catch you next time.